So Kronos is like the worst video game character that's ever existed, and I hate the entire God of War franchise. Just throwing it out there. All right, so we're going to put all these pieces together right here, right now. And to do this, we're just going to jump in with an example, and we're going to tie a bunch of these pieces together. It is super important when we're tying together like ideas throughout, like over the course of the last month and a half. If you don't understand something right at that point in time, what do? Please ask questions. There's a lot going on in this problem, and I'm going to show some stuff that I'll write in my pink color when we need, but here's what I want to do. We're going to consider, and what I'm going to do is I'm actually going to break this problem into like 3 different ABC parts, but in reality, when you see it on the homework, it probably won't be ABC. It's just one big problem. Okay, what's up? When you get the homework for this, yes. So I want us to consider the function f of x equals x to the 4th minus 2x cubed minus 7x squared plus 8x plus 12. Okay, couple things immediately, and I'm going to allude to something that we haven't truly written yet. What is the degree of this function? 4. Okay, I'll tell you right now, I think I know how many roots I'm expecting to find. Do you? Think about a quadratic crossing, like an x squared. How many roots does it have? There's only 2 places it can ever touch the x-axis, right? When we looked at the cubics, all 3 of them that were both of them that we saw on the graph, there were 3 x-intercepts or 3 roots. I think there's going to be 4, and we'll see if that really shakes out. And if it does, then we'll write a theorem about it. So from this lovely thing, what we're going to do is we're going to say on part A, and just so you know, the end goal of this is we're going to find all zeros. That's what the end goal is here. We're just going to break it into parts. So part A is I want us to list the possible, not list the possible. And I'm going to write this goofy Q here. It's a Blackboard Q. What does this stand for? Why would a Q stand for rational? Quotients. Ratios are fractions, and fractions are division. These are rational roots. Okay, possible rational roots. So here we go. And I typically write this as pos for my shorthand, Q. Okay. Now, this is the theorem that we saw at the start of class that your classmates explained to you that we ran over briefly. I know that right now, if I wanted to, I don't think we could factor it. I can't even try grouping because how many terms are there? 1, 2, 3. I can't make 2 equal sized groups, so grouping doesn't even have a chance of working. Okay, which means if we didn't do this, I'm just hoping that I randomly pick one of the infinitely many choices that will work. If we tried, what number might you pick? Like if you have no idea to say where's a root or a factor, what's a natural first start? 1. I'm just going to check a couple real quick to see if it works, and we'll see if we stumble upon it. 1 is nice because it's easy. 1 minus 2 is -1. Minus 7, right, is now -8. Plus 8 is 0. Plus 12 is 12. That was not 0. That's not a root. So 1 didn't work. What might be the next number I try? 2. We could check it, right? And then if that didn't work, we would try probably 3 is my guess. Is there any reason, anybody in here, like, we're just not going to say a number that I haven't said. I said 1, 2, and 3, right? Okay, we're actually just going to do this because this one's going to work out really nicely. Instead of just randomly guessing, let's see what shows up and just check those. So for our possible rational roots, they're going to happen, if they do occur, at x equals plus or minus, and I'm going to write this out like we did yesterday. It's P over Q. Where does this number P come from, though? Factors of something. The constant, this term. So here we go. What are the factors of 12? And I'm going to start at the beginning. 1 goes into 12 for sure. 2, 3, 4, 6, and 12. These are all the possible factors of 12. Okay, in the denominator, this is nice here. What's the only possible factor of the leading coefficient here? And what is the leading coefficient? It's a 1, and the only factor of 1 is 1. So in this, if I made you do the entire problem like we do in pre-calc, you would either have to learn how to use your calculator to do this, or you would have to hope that it happens quickly and use synthetic division to check 1, 2, 3, 4, 5, 6, positive or negative, so 12 possible numbers that work. Okay, here's the cool part, and I'm going to sneak a little bit ahead just to give you a preview of some stuff that we see in pre-calc. These are all the possible numbers. Am I ever going to check 1/2? Like, would it ever make sense? Is that one of the numbers that shows up here if I match numerator and denominator? No, it's either going to be 1 or 2 or 3 or 4 or 6 or 12. So we already saw 1 didn't work. What might we try? 2. Now, I want you guys to do this one with me. 1 didn't work. We checked it in our head. We're going to say check PQ list for roots or zeros, whatever way you want to word it. Now, when we do this, remind me, have we ever seen anything where if we get something as a 0, we knew it was a factor or a root? Like, that's a big question. I'm going to do something just random over here real quick. If I take 18 divided by 3, it's 6, right? Yeah. Where does 0 show up in this problem? And what is this? The remainder. If my remainder is 0, we found a root, right? Okay, we're going to use that idea. If we already checked 1 and it didn't work, what's the next possible number that's naturally showing up on this list? 0, or sorry, say it again. 2, okay. Now, I'm going to say we're going to check this P over Q value using division. And here's where you get a little bit of choice in this matter. I have to divide using these numbers. Now, we can call it division or we can call it synthetic substitution, which is where we plugged it into the synthetic stuff, and the remainder is our value. I'm after a 0. I tried 1 just now. We're going to try 2, and we're going to do it synthetically. And if it works, awesome. If it doesn't, less awesome, but we'll check 3 after that. So we're going to do a synthetic check or long division if you'd rather. Anybody want to do long division? Okay, cool. I'm fine with that. Let's check 2. I'm going to do this one in white just so we can stay consistent. We're going to check if, and this is wordier than you'll ever write, x equals 2 is a root. Now, I am going to put an IE here, which is just the fancy Latin version of in other words. And this is a big connection that we started class with yesterday. If x equals 2 is a root, can you tell me the factor? If I made it so there was a 0 on this side, I would have to just subtract a 2 over. So whether I'm saying x equals 2 is a root, another way that we could word this is just simply is x minus 2 a factor? These are the same question. Is it a root and is this a factor? They're related, certainly, and they're almost synonyms of one another. They have the same meaning. Okay, so if we wanted to long divide, we could use this. Or if I want to do it synthetically, what goes outside of my synthetic box? A 2. Okay, here we are. What goes inside this top row of my synthetic division box? 1, -2, -7. Where are these numbers coming from? From the equation. They are the coefficients that show up in my divisor. Now, I was paying careful attention, but it wasn't clear because I was letting somebody else read it. Are we missing any powers? Yeah. 4, 3, 2, 1. Nope, we're good. Okay. You always have to check, because if you are, what do you put in place? A 0. So I don't remember how to start synthetic division. What do I do? Indeed. 1. Now what? 2 times 1 is 2. That's a 0, right? 2 times 0 is 0. That's a -7. That's -14, -6, and -12. What did we just determine? So no remainder, I agree. Now I'm going to do this one in purple. This is not a true part of the problem, but this is an important aspect to it. We just found that x equals 2 is a what? So not quite. Like you're pretty much, but I'm going to fix the language. X equals 2 is the root. So I'm going to write this here. The fact that we plugged in 2 and got a 0, we could also call it a 0. We're just going to say this means or implies to me that x equals 2 is a root. Or in other words, i.e., what's my factor? X minus 2 is a factor. Okay. Now, as we do this, part B rather, and I'm just going to sneak it in here, check PQ for roots using division. We just did that. It is a root. Okay, I'm going to sneak this in as part C, but again, I just want to highlight, in the actual problem, there's not A, B, and C. It's just do all of this. I'm just kind of helping. These are like essentially my steps, just so you guys are aware. Okay, on C, here's my challenge. I want to write our lovely function f of x in factored form. Okay, we are almost there already. Can you tell me one of the factors of f of x at this point? X minus 2. We just verified that using division. Like, that was the whole point of doing this. And luckily, we stumbled upon 2 pretty quickly. So if I want, I think it's reasonable that I can say, instead of writing f of x is at x to the 4th mess, I know that one piece of it is x minus 2. That's one of my factors. What's the other factor? It's these things, right? These are the coefficients. What did my function start at? Which degree? To the 4th, which means if I divide it by x, I'm down to the 3rd, right? So when I'm looking at these coefficients, these are my quotient coefficients, and I know it's just 1 degree less. So if we started with x to the 4th, this is 1x to the 3rd minus 7x minus 6. Now, notice I did not write plus 0x squared, and that's okay. Say that again? So can you ask your question again? Because I think other people probably have it. Yep, so here's my x cubed, here's my x squareds, here's my x, and here's my constant. Okay, these all match up. That's how I'm getting these numbers. Okay, we now look at this thing, and unfortunately, I don't think it's going to work super nicely. But here's the cool part of it. I know that this factor can't be done anymore. Can we factor this like normal? Can we? What's weird about this one? It's a trinomial, but there's something different than every other trinomial that we've done. It's a cube instead of a square, right? We can't use those regular rules. So here's the good news. If I want to find if something's a factor of this, we can guess and check, or we can make a nice list. Now, it turns out that if we make the list, and I'm going to make us make the list just so you know, it's the same list as before, just with some stuff taken out. So let's just do this real quick. I'm going to say PQ list right here, PQ, and let's just see, it'd be plus or minus. What are the factors of the constant on this one? 1, 2, and 3, and over 1, because it's still my leading coefficient just in here. Now, we happen to have to do it twice. I'm sorry. And 6. I'm sorry. Thank you. We happen to have to do it twice on this problem. It's the only problem. Definitely not on your test will this happen. But it can happen, and it does happen in classroom setting. On homework, it could. Okay. If I'm trying to check these, I'm probably just going to check it in my head because it's easy enough to plug in. If I have these numbers, 1 over 1, 2 over 1, 3 over 1, 6 over 1, the positive and negative, where's a natural starting point? 1? Okay, so let's try it. 1 minus 7 is negative 6. Minus 6 is negative 12. Was that a 0? So 1 didn't work. Negative 1, let's try it. What's negative 1 cubed? Negative 1 plus 7 is 6, because minus and negative 7, minus 6. It worked. Just now, it worked. And we didn't have to do a big fancy all sorts of stuff. We got negative 1 to give us a 0. Now, is it possible we made a mistake in our mental math? We can verify it. We're now going to check for this one. Let's check negative 1 and just see if it works. So I'm going to put negative 1 outside my box, and I'm only working with these ones. So here we go, negative 1. In this lovely cubic thing, what numbers go up top, Lando? How many x cubes?
1.
How many x squareds?
7.
Try again.
0.
Good. How many x's?
7.
One more try.
Negative 7.
Love it. And negative 6. Verify that this is 0. Run the synthetic division. Let's see if it is, in fact, a 0. Lily, did you get 0? Awesome. I think it works. Now, here's the big question. What did doing this again, like we had to do it again because we couldn't factor this cube. That's the only reason we had to do our PQ list again. What did this just give us? Another 0. Where's my other 0? Same thing that we did before. X equals what is my 0? -1 is 0 or root. And in turn, I'm just going to use a semicolon this time. If this is my root, if I want to make it equal to 0, it turns into x plus 1. And I just get that by adding 1 to each side of this. X plus 1 is a what then? Factor. Now, we're almost done with this. And this problem is much grosser than the normal ones, but it's a good thing to do as a class if we can do this big, ugly problem together. When you get easier problems, they'll be nice. So let's check it. Right now then, can I write f of x instead of just this? Can I write it more factored? Well, let's try, because if there's not a clear answer there, we already knew this was a factor, right? X minus 2. So it's still here, x minus 2. What other factor did we just find in this? X plus 1. There's one more factor that we have a little tiny bit more work to do with, but we're just about done. Can somebody tell me my last factor here? 1x squared minus 1x minus 6. So x squared minus x minus 6. Okay, bless you, I think. We are just working our way through to be more and more factored and simplified along the way. Does x minus 2 factor any further? No. Does x plus 1 factor any further? No. What's nice about that trinomial, though? It's squared, certainly. It's a quadratic, and the leading coefficient is 1. How does this shortcut for factoring work? So perfect squares are a good thing to check if that's what you're referring to. Why do I care that's a 1? Because I can't take the square root of -6, not nicely, so it's not a perfect square. Shortcut, how do we use a shortcut? Are there factors of -6 that add up to -1? So 2 and 3 won't work because that's +6. So that's -6. If we do -3 and 2, do those work? Now, normally, like on the test, I'm pretty sure it's a cube, so you don't have to do the PQ list twice, just so you know. But let's write this completely factored then, and we're at the end of this part. F of x, it had an x minus 2. It's still here. We don't lose it. It had an x plus 1. It's still here. We don't lose it. What are my last two factors if we use our shortcut? X plus 2 and x minus 3. At this point, do we have a completely, entirely factored version of f of x? Okay, and that was what C asked us to do. This is the most factored form of f of x. This is it. This is our factored form. So factored, I'm just going to write it here. Again, the purple or pink or fuchsia, whatever color you guys see, is entirely optional. Okay, any gut feeling what my last question is going to be? What are the zeros? So if we have the factors, are the zeros easy to get? So here's the ending part of this. Find all zeros. And it turns out if we have the factored form, incredibly easy to do. I know that these things are all going to multiply to be 0. Like that's the goal here. Amy, what value of x makes this one 0? 2. Love it. Perscovia, what value of x makes this 0? Love it. Kyle, what value of x makes this 0? Perfect. And Fredward, what value of x makes this 0? Love it. Okay, we have successfully factored and solved a 4th degree function. And I do want to highlight real quick, how many roots were there? There were 4 of them. Now, it turns out, I'm not going to give you homework today. Real quick conversation about what's going to happen the next few days. Today's Wednesday, correct? Cool. Tomorrow in class, I'm going to give you guys like 25-ish minutes to do several of these. And then we are going to knock out the very last section. I'm going to gloss over it pretty quick because I know we're going to see a bunch of it again. We have been going pretty slow. We're going to have to speed up second semester. Just a heads up. Okay. With that said, tomorrow we're going to get like 25 minutes for homework, 25 minutes, or classwork rather, 25 minutes to look at the next section, at least very briefly. And then Friday in class, we're going to take a practice test. We have practice cumulative tests that I'm going to hook you guys up with. And we will take Monday to study and review. Tuesday will be our final. Okay. There is no final schedule this year. It is a 1-hour test. Michael, how hard was it, in your opinion? Not terrible. What surprised you about it? Like, don't give any, like, I don't even care because I'm going to give the test you took as a study guide. What was the hardest part of it for you? Little mistakes. What chapters were in it? Did you do linear stuff? So chapter 1 showed up. Did you do factoring? Chapter 2 showed up. Did some of this stuff show up? Chapter 3, hey, look at that, all 3 of them. Okay, tomorrow, come prepared and ready to work. If you want to go through number 27, because you didn't get a chance to, because I didn't post a video, please watch that tonight. Sophomores, anybody who wasn't here. After school ready, Lai? Baller.